today we are starting to talk about inverse functions. So inverse functions applies to all functions, but we are pretty much going to be sticking to linear for this point. You might see a couple other graphs that are not linear, which we'll be able to figure out inverses of very easily, but when we get to the algebraic part of calculating inverses, we will mostly stick with linear for now, and then as we get into our other functions, we will touch base with inverses at that point in time. So to start us off, we're going to start with points. So to find the inverse of a relation, which remember that does include functions because functions are still relations, they're just a more specific relation. All you're going to do is you're going to switch your x and your y values. That's all we have to do for inverse. You're just going to be switching those x's and those y's. So, as we can see in my example here, x from your original point in your inverse goes in the y position, and then your y from your original point becomes the x in your new one there. So this point 2, -3, the inverse of it would be the point -3, 2. So you're just flip-flopping your x and your y values when you have your points. So if we take a look at our examples for those ones, if I have 3, 4, 1, -2, -5, -1, my inverse for that, each point I'm just going to flip-flop. So I would have 4, 3, -2, 1, and then -1, -5. Those would be the inverse points there. Zoom in a little bit more for you. So my second example there, 0, -2 would become the point -2, 0. -1, 4, the inverse would be 4, -1. And then -2, -2, the inverse would be the same point, -2, -2. So we're just flip-flopping those. Same thing would happen in your table. So here I have my set of points just written in a table form instead of like the coordinate points that we have over here. But the process would still be the same. You're still just going to flip-flop. So -2, -3 would become -3, -2, 0, 1. And then 3, 4 would be the points of my inverse. So if you have sets of points, whether they are written like coordinate points or in the table form, you just flip-flop those x and y values. Let's take a look at a graph. So graphs of an inverse function. So graphing inverse functions. So graphing inverse functions, what I find to be the easiest method is I find points on the original graph. So for example, this point here, that would be the point 0, 3. And then I have this point here, which is 1, 2, 3, 1, 2. So I got the point 3, 2. So I like to find the points on the graph that I can see. And then I just flip those. So 3, 0, 2, 3. And then I create my graph with my flipped points. So 1, 2, 3, 0, 1, 2, 1, 2, 3. And there is the inverse line. So what we're actually doing when we do that, when we flip those points, is this line right here. That line right there. That is the line y = x. We refer to that as the line of inverse. So that line of inverse, what we're actually doing is we're taking the original function and we're just reflecting it over that line of inverse to create the inverse function. And so the easiest way to do that is just flipping your x and your y values. That's how we actually do it. But what is happening, what is physically happening, is we are reflecting our functions over that line of inverse, the line y = x. So if we look at our examples in here, I have my line here. So again, I'm just going to draw in my line of inverse. So I'm going to be reflecting my line over that line of inverse. But kind of like we had tricks in geometry when you were doing your reflections or your rotations, our trick here for reflecting over the line of inverse is to switch those x and y points. I've got a point here on my original 1, 2, 3, negative 3, 1. I have this point here, 0, 2. I have this point here, 1, 2, 3, 1, 2, 3. And then I don't have another point aligned nicely, so I just have an extra space in my table. But these three will work fine. That'll give me plenty in order to create my inverse function here. So I'm just going to flip my x and y's. 1, negative 3, 2, 0, 3, 3. So I'm going to plot those. 1, negative 3, 2, 0, 3, 3. And so there is my line of inverse, my purple line there. Try to make it a little darker for you to see a little bit better. So there is that line, inverse function. I'm sorry, I said line of inverse. That is my inverse function there. So then what do we notice about the graphs? They are reflections of each other. Over the line. I can't spell today. Line, y equals x. I put a y at the end of line. That doesn't go there. So inverses are reflections of each other over the line y equals x. Even if you aren't graphing them like we did in this example, they're still reflections of each other over that line y equals x. My example up above, if I were to plot these different points on the graph and then plot their inverses, they would be reflections of each other over this line y equals x. Because again, that is our line of inverse. Line of inverse. All right, so everything is a reflection over that line. Our inverses are reflections over that line. All right, one more way to do it. So when we are trying to create our inverse function equation, so one thing that's new here is our notation. That right there, that is f to the negative 1 power of x. So we just read it as f to the negative 1 of x. But this is our function notation for an inverse. So whenever you see this symbol here, that means we have an inverse. So these two functions right here are inverses of each other. So let's take a look at our steps. I wrote them out on the inside for us. So steps for writing the inverse function. So you're going to first take your f of x. If you have your function notation, you're going to take that and you're going to first replace that with a y. We're going to switch your x and your y values. You solve for y, and then you just replace with your notation for your inverse there. So let's take a look at our first example here. So again, following my steps. I have my function notation, so I'm going to first replace that with a y. There's step 1. Step 2 tells us to switch the x and the y, which a lot of people for some reason kind of overthink that step. You are literally just putting x where y is and y is where x is. And this goes along with what we did with our points. We flipped our x and our y and our points for both up above and for the graph. So we're switching our x and our y in our equation as well. So step 3 tells me to solve for y. So I'm going to add my 2 over, and then I'm going to divide by 4. So I get x over 4 plus 1/2 or x plus 2 all over 4. So then we just replace our notation. So I could even write this as 1/4 x plus 1/2 equals f to the negative 1 of x. There are a lot of different ways that we can write this first side here. So this is one way, 1/4 x plus 1/2. We could write it as this one here, the x over 4 plus 1/2. We do want to try to stay away from the x plus 2 over 4, because remember, we talked about this last unit, that is not fully simplified. These two are more simplified than that one is. All right. So although, yes, this is correct, we can go further, and you want to go further with that. So either of these two with your function notation, our answer. So that's going to be our inverse. So this equation, this inverse of this equation is that. All right, let's try again. So step 1, make it y equals instead of my function notation. And you might have equations that already have y in there instead of the function notation. So that's fine. But we want to make sure this is y equals. So then we switch our x and our y. So now it's x equals. I'm going to solve for y now. So I subtract my 5. Divide by 3. And then I'm just going to replace it with my function notation. So there is our inverse equation. So again, all of our inverses is reflections over that line y equals x. If you have points, you just flip-flop your x and y. If you have a graph, find your points, flip-flop your x and y. Equations, again, you're flip-flopping your x and y. You're just resolving and rearranging that equation for your y value.